around the expander received the same, ordered the flow of steam to the reactor to be increased, but mixture was flowing through the air side of the FCC unit and moving toward the ESP, flammable hydrocarbon. April 17, 2013. An enormous explosion rocked the city of West Texas when 30 tons of fertilizer-grade ammonium nitrate detonated. The blast killed 15 people and
Looking at the accidents in those videos, it's possible to see at least 3 characteristics of these sites that can actually influence the impact of the explosion in those locations. One of which is the process flow direction, the second is the spacing of the different units, and the third is the safety considerations. The purpose of plant layout is to reverse engineer these characteristics during the design process in the arrangement of the different units and equipment. Hi there, and welcome to Aquadelta Tech. This is Oil and Gas, Power Plant and Industrial Facilities Engineering, Part 4. And here we are going to be discussing plant layout. We have established several terminologies in the commencement of this series right from part 1. One of which was that we are going to lump together oil and gas, power plant and industrial facilities, not because they are the same, but because they are similar in terms of magnitude and complexity. We have also established that these terminologies can be interchanged from time to time, but we'll also elaborate on the different aspects that are unique to the different categories of engineering facilities. In part 4, we are going to be looking at the overall layout of a plant facility. Then we are going to look at how it relates to the direction of the wind with respect to the site. Then we are going to look at considerations and recommendations provided by the Global Assets Protection. Then we'll look at what an HAZID session entails. Then we're going to discuss briefly on the arrangement of equipment within a unit. Finally, we will conclude on this talk and talk briefly about what is going to be discussed next in this series. As a quick reminder, this is in part a review of the videos done online by Herve Baron on Oil and Gas Engineering Guide, as well as on the book by Aquadelta Tech, which is on Onshore Structural Design Step-by-Step Calculations. In terms of the general arrangement for a plant facility, the direction of the wind is one of the most important criteria in the initial stages. The direction of the wind, seeing that wind can actually aid the transfer of combustible fluids, toxic fluids. When I talk of fluids in terms of gases, it could also be liquids. It can also influence the direction during an explosion or a fire. So, in terms of from the upwind or the upstream of the wind to downstream of the wind, the less volatile facilities and units are placed in the upstream direction, while the more volatile areas that are more susceptible to explosion and combustion and more flammable are placed in the downstream segment. Looking at this schematic on the screen, you can see that the cars are parked at the uppermost section of the wind direction. Then it proceeds to the administrative building. Then from there you go to the control units, where you have the control and computer and the rest, which controls all the other processing units of the facility. From there you are going towards the processing units, where you actually process the fluids. Then finally to where you have storage, because at the storage you have the highest quantity of these flammable, combustible or more volatile substances. In the case of a refinery where you have a flare for combustion, you can actually place this flare equipment and exhaust at the crosswind section of where you have the processing units. So they'll be parallel with each other, but in line in terms of what position they lie from upstream and downstream of the wind direction. With respect to power plants and industrial facilities, it's also similar, but each of them are unique in terms of the kinds of equipment and processing units that are required in those facilities. So once again, in the design of the initial plant layout as well as the orientation of what direction the layout is going to take, it depends upon the prevailing direction of the wind from upstream to downstream. We initially looked at the plant layout for an example refinery which is on land. Previously, we looked at the plant layout for probably a refinery which is on land. But here we are looking at a kind of miniature refinery, but this is an offshore floating platform. You can also see here production area, utility units, as well as area for personnel. So in this diagram, it has been marked out for easy understanding. The red area is the most volatile, where you have production going on. The blue area is where you have the utility units and the control room and other similar facilities. Then the green area is where you have people, admin buildings, and the likes. So it goes from the most volatile, which is red, to the least volatile, which is green. The utility units or the control units is placed at the middle in a way that when there is a catastrophe looming at the volatile section, you can actually still control the whole facility at the units, at the utility units segment on this offshore platform. So it prevents accidents from getting to where the personnel are in most cases. So those are some considerations when it comes to an offshore platform, which is similar to what we have previously defined for a facility which is on land. So after ascertaining the direction of the wind and doing some preliminary positioning of the different units, it's important to consider the process flow direction, which will determine which is the most volatile unit in the system. From there, you are looking at space requirements. For example, the size of an equipment can determine how much space you need on ground. A 5 megawatt, let's say a 5 megawatt turbine will be different in size from a 50 megawatt or a 200 megawatt turbine for a power plant, just as an example. So the size of the equipment determines how much space is required. Also, how much space you need to access such kind of equipment, as well as the maintenance. If you are going to bring down this equipment to repair it on site, or if you are going to move it to a different facility, which area within this layout of the plant is going to accommodate such kind of equipment. So those are some considerations we'll make. Other considerations is for safety. For example, if you have a small explosion due to gas in a 15 kg cylinder, the distance of this explosion is going to be less than if you have a drum of, let's say, 1000 liters of, let's say, petrol. So the impact of the explosion and the distance it's going to travel is going to be different. There are several codes of practice which recommend different distances for different quantity and size of a storage facility. One of such recommendations is also provided by the Global Asset Protection, where they have described both inter and intra equipment spacing. For example, if you have two fractionating columns within each other, the distance between them can be described. Then if you are talking about between a fractionating column and, let's say, an administrative building, there is a different kind of distance that is also recommended. The different features of this GAP recommendation is currently displaying on your screen. So you can see how the different kinds of equipment are listed with respect to their classification under the GAP standard, and from there you are able to give it a particular distance. So if you are talking of intra within itself, you are going to know this is the kind of distance you are going to recommend during the layout design. And when you're talking of inter, between other facility units, you know this is the amount of distance that is going to be recommended. So upon carrying out the initial drawings and planned layouts, there is a review session amongst different professionals called the Joint Hazard Identification, or HAZID for short. And this involves the different engineering units where they look at it critically based on the different codes of practice and areas of the layout which pass the different recommendations are given a go ahead, and the ones which need to be reviewed or repositioned are actually marked out, as you can see there on the screen. So the different units, the ones that pass, the ones that don't pass, and the ones that need to be additionally scrutinized or analyzed are all indicated during this HAZID process. It's important to do this because it's from this stage you are able to ratify and agree that this is going to be particular layout for the facility because it has passed the various criteria in the various codes of practice. So upon completion of the plan layout or simultaneously, the vertical orientation and the elevation of these different processing units also needs to be considered. On your screen is a steel structure which is housing some processing units. Let's say for example a horizontal vessel, and these horizontal vessels are supported on one segment of the facility, and above it probably you have some steel sections that are enclosing it in a kind of like a housing. Selection of the housing is dependent upon how easy it is to access this horizontal vessel in the event of a replacement or maybe maintenance is required. Some of these are considered in the vertical direction, so it has to be looked at critically. So those same three characteristics in reverse engineering into plan layout, the process flow, the space requirement, as well as safety considerations are also considered during the vertical orientation of the different equipment in the processing unit. So on your screen is a brief schematic of how the different drawing stages is going to take place. So the first stage is issued for review. Then the next stage is going to be issued for design, and the last stage is issued for construction. In the issued for review stage is where you have your initial planned layout which you carry out along with the joint session of the HAZID and the other different arrangement of equipment in the unit and the similar required processes. All of this take place in the initial issued for review stage. Once this is done and there is consensus, it is then issued for design. Upon holistic design, which includes some other criteria in terms of sizing and strength and the rest, it is then approved and issued for construction. Those are the three stages of drawings that are done for a planned layout. So we have looked at different considerations in planned layout design, one of which is the direction of the wind from upstream to downstream, which determines the position for volatile and non-volatile units of these facilities. From there, we have also looked at important characteristics to be reverse engineered during the plant layout design process, one of which is the process flow direction, then another is the space requirement, as well as safety considerations. All of this we have done. From there, we're able to look at the HAZID section, which is the hazard identification section, which is where you do a lot of review on the different drawings that have been provided. Then we looked at the three different stages of drawings, which is issued for review, issued for design, and issued for construction. It's from these we are able to establish the required plant layout for an oil and gas, power plant, or industrial facility. In the next video of this series, we are going to be looking at safety and the environment. So until next time, Aqua Delta Tech, where we create for better living.